Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. We're going to be looking tonight at the Math Work 1 homework for worksheet 4.5. Remember that every problem on the homework help mirrors an exact problem on your homework. So if you're having a problem with a particular homework, fast forward to that problem and we should be able to help you. So let's get started. Problem 1 asks, is the point -1, 5 a solution to the inequality y is less than 3x plus 6? Well, just like we do with an equation, if we want to find if it's true, if it's a solution, put the point in and then see if you arrive at a true statement or a false statement. A true statement would mean the point works and is a solution. A false statement would mean it's not. So let's plug this in here. So for y, we're putting in 5. And then our point is less than 3, and then times x we have -1 plus 6. Okay, so now we end up with 5 is less than 3 times -1 is -3, so -3 plus 6, so we end up with 5 is less than 6 minus 3 is 3. Well, 5 is not less than 6 and 3, so this is a false statement, which implies then that the point -1, 5 is not a solution. All right? If we'd gotten something like 5 is less than 7, then we'd have known, oh, that point works. All right? So that means what we have here, if I was looking at it graphically, this is a point that starts at 6 and goes up like this. It kind of goes up like that. And we're looking at all the points that are less than this. And it must mean that the point -1, 5 sits up like this. So in other words, it's greater than, not less than. Problem 2 asks us to graph each linear inequality. Well, the first thing we do with a linear inequality is we graph what's called the boundary line. Now the boundary line is simply the line, if I got rid of the inequality and just made it an equation, y equals -3x plus 2. Okay, so I know from my linear studies last unit that this is my slope, -3, and this is my y-intercept 2. So if I were graphing it, I would come over here and go to 0, 2. There's 1 point. And then my slope is -3, so that's -3 over 1. So it would be down 3 over 1, down 3 over 1, down 3 over 1. And I can even go backwards, up 3 and back 1, etc. Now the next question is, I have my inequality here. Well, the equal part tells me that that's going to be a solid line. The equal part means that part of this equation is it can either be less than or equal to. Well, the line is all the parts that are equal to. Because it includes the equal to, this is part of the solution. And so we can draw our line here. Okay. So there's our line. All the points in that line satisfy that because they satisfy the equal part. The less than part, however, tells us that we're also looking for all the parts that are less than or below the line. Okay? So if you pick any point here, like if I pick this point here, and I look below, I'm looking at all the points that are down here. Likewise, all the points down there, down there, down there. So my graph becomes all of these points here below. Sometimes if you had colored pencils or something, you might want to color it in with something. I could color it in like with an orange here. See if this works. And I could come in here and graph this and say, okay, I want everything below here. All right, so let's go below. So everything below the line, in other words, everything over on this side is part of my solution. Okay. So that's the graph. Everything either on the line or in the shaded area is a solution to that inequality. Problem 3 asks us to graph the inequality x is less than minus 2. Once again, let's think about what the boundary line would be. The boundary line would simply be x equal minus 2. Well, that's a vertical line, and I go out here to x equal minus 2 over here, and I realize that it's the vertical line there. Now, before I draw the line, though, I got to come back and say, oh, this is less than. Notice there's no equal. So that means my line has to be dotted, because the dotted means it's a boundary, but it doesn't include the boundary. So for my graph here, I'm going to have a dotted line. Okay, so it's not included. Any points on that line are not less than minus 2 because they're equal to minus 2. Now in this case, though, I see the less than part. Normally that means to go below, but how do you go below that line? Well, it's pretty easy to realize if this is minus 2, what's less than minus 2? That's going to be minus 2. All right, so this means that it's my shading is going to be everything on this side. So everything on that side. If I use this again. So everything on this side is my graph. And by the way, you can always check it. One easy way to check is to pick a point. For example, let me pick the point 0, 0. Okay? 0, 0. According to my thing here, according to this, 0, 0 shouldn't work, right? It's not in the grade. So let's see. Is 0 less than minus 2? No. So we would expect that not to work. On the other hand, here's the point. Here's the point minus 3, 0. And look here, if we plug that in, minus 3 is less than minus 2. So notice the area in the shade solves the equation. The area outside the shade does not solve the equation. Problem 4 is kind of the reverse of the others. This time they're giving us the graph and asking us to write the inequality. Okay, so first thing we need to do is look at the boundary line. What is the boundary line? In our case, I notice that it crosses the y-axis right here, and that's the point 0, minus 1. So that means if that's my y-intercept, it means that in my equation, b equals minus 1. Now we want to find the slope. So if I look at the slope here, I could take the slope and go up, make my little slope triangle up there and over here. So here's my slope triangle right here. And notice on the slope triangle that it goes up 1 and over 2. So my slope is the rise over the run, so it's 1 over 2. So my boundary line then I can write as y equals 1/2 x minus 1. Now notice, however, that our equation, first of all, is dotted. So that means when I come to the inequality, I'm going to have y, and I'm not going to have the equal sign. Second thing, I notice that we have everything below the line, so that makes this a less than 1/2 x minus 1, and that's my inequality. Notice two things. The dotted line means I don't have less than or equal to, and then all my shaded area is below the line, so it's less than, not greater than. The vocabulary question asks, how is a linear inequality in two variables like a linear equation in two variables? Well, how are they alike? Well, first of all, they both describe points or ordered pairs, x, y, that are solutions to the equation or inequality. Now, where they're different is the equation graphs as a line. Only the points on the line are solution, and that's it. However, for an inequality, it graphs not as a line, as a region or a portion of the graph. In other words, if I'm graphing an equation, I might get something like this, and only the places on the blue are solutions. If I'm graphing an inequality, however, I might have the same line, but now I'm noticing all the points that, for example, are less than everything in there. So I actually have a whole plane of answers, whereas on the equation, I only have a line of answers. So that's one of the big differences between the two. Problem 6 asks us the question, to graph the inequality here, y is less than 3/2 x plus 3, do you shade above or below the boundary line? Now notice I can't always answer this question directly, but in this case, because I already have it in the y less than mx plus b line, I can just simply look there and say, okay, I have a less than, so less than implies that I'm going to graph below the line, okay? Anything below the line. Equal would be equal to the line, but less than means points below the line, so we would shade below on this question. Problem 7 says that a student with 2 summer jobs, he earns $12 per hour at a cafe and $8 per hour at a market. He would like to earn at least $1,200 per month. All right. So let's write and graph the inequality. First of all, I'm going to let x equal number of hours at the cafe, and y equals the number of hours at the market. Okay. So when we look at how much he earns, he's going to earn $12 times every hour he's in the cafe, plus he's going to earn $8 times every hour he works in the market. All right. And we want it to be at least. Well, what does at least mean? I want it to be at least that amount, but it can be more. So what I'm looking at least implies greater than or equal to. I want it to be at least, but it can be 4. It's like saying you have to be at least 16 years old to get your driver's license. Well, you can be 17 or 18. You can be older, but you can't be less than. At least is the smallest number you can be, but you can be greater than. So our inequality is going to be greater than or equal to, at least, at $1,200. Okay? So let's look at our boundary line first. Our boundary line is simply 12x plus 8y is less than or equal to 1,200. Now problem 8 is an error analysis. It says a student graphed y is greater than or equal to 2x plus 3 shown at the right. Describe the error. Well, first of all, I noticed that here's my slope. Slope is 2. And my y-intercept b is 3. So I look over here, 1, 2, 1, 2, 3. That looks good. And my slope up 2 or 1. So there wasn't a problem graphing his boundary line, 2 and 1. What the problem was is this is greater than, and greater than implies or implies shading above. And he's shaded below. So to correct that, let's just draw our boundary line. Again, greater than equals solid line, because it has the equal part. So if I come up here to plus 3, and then go up 2 over 1, and then back down 2, back 1. It's a solid line again, so I can draw my line there. But this time, because it's greater than, we are going to shade in the side to the right. So my answer is everything, the side to the left. Everything on the left. Because see, everything on the left, if I picked a point, is everything on the left is above the lines. See, we're going greater than. So it's in the area that is above the line. All right. All right. Hope that helped tonight. See you in class.